For problem number 10, we have a merry-go-round is rotating at the constant angular speed of 3 rotations per minute counterclockwise. The platform of this ride is a circular disc of radius 24 feet. You jump onto the ride at the location pictured below. A is if theta is equal to 34 degrees, then what are your XY coordinates after 4 minutes? So basically what we need to do first is figure out where we're going to be at 4 minutes, but with a rotation of an even number, 3, by a whole integer per minute. We know that every minute he's just going to end up at the same place, just having gone 3 times around. So for part A and part B, we just need to solve it for angle 34 and 20. So to do that, we go ahead and create a reference triangle with 34 as our angle, and then just use our angle and our radius to find, and then our knowledge of sine and cosine functions to solve for these sides of the triangle, and you get 19.9 and 13.42. We do the same thing for 20, and we get 8.21 and 22.5. Or sorry, 22.5 comma 8.21. For C, it's a little bit trickier because the problem asks if theta is negative 14 degrees, what are your XY coordinates after 6 seconds? And after 6 seconds, we know that he's not going to be in the same spot. He's basically going to be 1/10 of 3 revolutions, because 6 seconds is 1/10 of a minute. And then it asks us to draw an actual picture of our. There's the accurate picture. Here's another accurate picture. So to do that, we do 1080 times 1/60, and that's going to get us 1080 because that's 360 times 3. I was just converting it to degrees. It was easier for me. Times 160 to convert to degrees per second, and then we multiply it times 6 to figure out how far he's traveled in 6 seconds. And we know that we do that, and it's 108, and then we subtract 14 to get 94. So then once we have that, we go ahead and figure out where 94 is on the triangle. From negative 14, we know that the angle is now 86 degrees, or this angle is 86 degrees, and we can create a reference triangle, use Pythagoreans, or use our sine and cosine functions to solve for the sides, and these are our XY coordinates. For part D, similar, except now theta is negative 2.1 radians, and it asks us to find the XY coordinates after 2 hours and 7 minutes. So to do that, first we have to figure out, at least I like to figure out where negative 2.1 radians is in degrees. So it's negative 120.3. Then you figure out how far he's traveled in 7 seconds, since every minute before that is just going to land him at the same spot. So we figured that he moved 5.7 or 126 degrees in 7 seconds. So you just do negative 120.3 plus 126.0, and you get 5.7. And then we can go ahead and make a reference triangle like you see over here, and then do the same thing we've been doing the whole time, and you get these coordinates. For part D, or part E, it asks if theta is 2.1 radians, then what are your XY coordinates after 5 seconds? So we know that he's traveling 90 degrees for every 5 seconds, and at 2.1 radians, that's 120 degrees. We add 90 degrees to that, we have 210, and then from a starting point, 210 lands on here. We just create another reference triangle and find these points. And that's it. Thanks.